Hi, I'm Dave from TRC. Welcome to our Heat Pump Boss series. Level up your heat pump installs. We've got the tools, tips, and how-tos that will help make you an expert heat pump installer. Today, we're going to focus on system design from the Manual J. Before we dive into system design, I want to quickly mention our previous video on heat pump system design from the Manual J. If you haven't already, I highly recommend reviewing it. In that video, we covered the importance of right-sizing your system to avoid issues like short cycling, poor dehumidification, and inefficiency. It's a critical step to ensure your heat pump performs at its best. Assuming we now have the right size system, let's focus on creating a system design that works for the building. This means matching room loads, choosing distribution methods that cover the whole house, thinking through how to pair zones on the same compressor, considering multi-compressor designs, and planning for good placement of outdoor units. Let's dive in. First, let's establish some goals. The ultimate goal of system design is to create a solution that 1. Delivers consistent comfort with reliable temperature and humidity control, 2. Manages costs, both upfront and during operation, and 3. Optimizes efficiency for long-term energy saving and dependable performance. By keeping these priorities in focus, you can design systems that not only meet customer expectations, but also operate at their absolute best. Designing heat pump systems involves several important considerations. Unlike traditional fossil fuel systems, heat pumps offer greater flexibility in distribution options. This makes it easier to create innovative solutions tailored to a home's layout. But remember, great design isn't a substitution for right sizing. Right sizing the system is critical to ensure the capacity at design conditions matches the calculated design load, delivering optimal performance. We'll talk more about this later on, but system pairing is a key driver of heat pump design. Pairing indoor units with spaces that share similar heating needs boosts both efficiency and comfort, while strategic outdoor unit placement ensures proper airflow year-round, enhancing reliability and extending the system's lifespan. Now we're going to talk about different distribution options. There's forced air. Forced air is a system that uses a network of ducts and vents to distribute heat or cooled air throughout a home. A central unit such as a furnace or heat pump generates the conditioned air, which is then pushed through the ducts by a blower. Next up is point source. Point source is a system that provides heating or cooling directly to a specific area or room without relying on ducts. Examples include ductless mini-split systems, space heaters, or window air conditioners. Next is a compact duct system. These systems are very similar to ducted systems. Compact systems also use a network of ducts to distribute air from a central unit. The difference is that the compact duct system is designed specifically for heat pumps, have a smaller blower, and fewer ducts with shorter lengths. They're also slimmer than your typical fossil fuel furnace duct. Compact ducts offer the opportunity to serve several small load rooms as a single zone, instead of having oversized indoor units in each room. These distribution options give you flexibility in how you design a system to meet the needs of the home. Properly sized systems will minimize the need for use of less efficient supplemental heating technologies like electric resistance heaters. Whether you're using forced air, point source systems, or a mixed solution, the goal is to ensure the system delivers comfort, efficiency, and reduced operational costs. But what if you want even more control over how heating and cooling is distributed throughout the home? That's where zoning comes in. Let's take a closer look at how zoning works and how branch boxes make multi-zone systems possible. We're all familiar with traditional heating and air conditioning systems. You walk into your home and set a single temperature for the entire house, a one-size-fits-all approach. Zoning, on the other hand, allows you to divide a home into multiple areas, or zones, each with its own temperature control. We're going to talk about a system with one compressor but multiple zones. You might be wondering how that's accomplished. The answer is a branch box. Branch boxes are a key component in a multi-zone system. They distribute refrigerant from a single outdoor unit to multiple indoor units. Inside the branch box are valves that open and close to control the flow of refrigerant, ensuring each indoor unit receives the precise amount needed for heating or cooling based on demand. This design gives the homeowner more control over their comfort, tailored to their specific needs. Additionally, it can help reduce energy waste. For example, if you spend most of your time in Zone 1, the living room, and only go to Zone 2, the bedroom, to sleep, you can set the temperature lower or higher in the bedroom depending on the season to avoid unnecessary energy use when you're not in there. Along the same lines of zoning design, there's multi-compressor systems. A multi-compressor system means separate one-to-one heat pump systems for different areas of the home. Multi-compressor systems are gaining traction in heat pump design, with 52% of air source heat pump projects in upstate New York for New York State Clean Heat now incorporating more than one compressor. These systems bring a range of benefits, including greater flexibility in distribution design, improved capacity matching for both zonal and whole home needs, and simpler refrigerant line runs. They also enhance system pairing and provide heating resiliency, ensuring reliable performance even in tough conditions. While multi-compressor systems may come with a slightly higher upfront cost, the increase is often smaller than one expects, making them a smart and valuable choice for many projects. For more information on branch boxes and multi-compressor systems, contact your manufacturer or wholesaler. In the spirit of zoning designs, let's establish something important. Not every room in a home requires a dedicated heating or cooling system. Know when to skip a room. Spaces like utility rooms, bathrooms, or home offices often have minimal external surfaces, resulting in low heating or cooling loads. If a room's design load is less than 1000 BTUH, it can often be excluded from the system. Similarly, rooms with free airflow from adjacent spaces, such as open floor plans or areas where doors are typically left open, may not need their own system. However, their heating and cooling loads must still be included in the capacity requirements of the indoor units serving those spaces. For open floor plans or areas where doors are typically left open, compact ducts or small electric resistance heaters can often be effective solutions to meet design conditions. By skipping unnecessary rooms, you can simplify the system design, reduce costs, and still maintain overall comfort. Let's shift to talking a bit about outdoor unit placement design. A heat pump can be sized perfectly and installed beautifully indoors, but if the outdoor location is not right, you're going to feel it, literally. There are three big factors to keep in mind during the design phase of placing outdoor units. First, airflow. These outdoor units need to breathe. Placing them too close to a solid wall can choke off airflow and hurt performance. Remember, clearances matter. Be intentional with placement. Look for areas away from shrubbery or debris-prone spots, like under a damaged gutter. Second, snow protection. Ideally, you want the heat pump on the gable side of the home. The eave side is where snow typically sheds off the roof. A big roof dump can bury or damage an outdoor unit. The gable end avoids that snowdrop and provides protection, especially when combined with snow deflectors. If the unit must be installed on the eave side of the home, snow deflectors are especially important and should be installed. Additionally, remember to protect the heat pump from snow accumulation below. Ensure the unit is elevated above the average annual snow height to provide adequate clearance. Third, refrigerant line and electrical wiring. Think about cost and ease of installation. A great spot for an outdoor equipment doesn't help much if it requires running 60 feet of line set through unnavigable house framing. Straightforward routing keeps the install time down, reduces chances for leaks, and keeps the job cost effective. Finally, noise. These units are quiet, but they're not silent. Placing a unit outside a bedroom window can lead to noise complaints due to low-frequency hum. Thoughtful placement can avoid these issues. Let's end with discussing cost reductions using design. As we've covered, right sizing is one of the most effective ways to reduce costs while maintaining system performance, but design plays a significant role as well. Yes, smaller systems are more affordable, but only when load calculations are accurate, so it's important to avoid padding manual J results. It's also always important to look for ways to reduce loads, such as improving air sealing and simplifying distribution by skipping unnecessary rooms or using modular design. Mixing and matching distribution methods like compact ducts and ductless heads can also streamline design, while avoiding overly complex duct systems ensures better efficiency. Moving ducts out of the unconditioned space is also another way to lower the load and boost performance. To improve air movement, consider using remote thermostats, transfer grills, or floor vents. Familiarity with common design strategies for typical housing archetypes can further be explored in NYSERDA's heat pump home runs, available at cleanheatconnect.ny.gov. By applying these strategies, HVAC professionals can deliver cost-effective, efficient, and customized solutions tailored to each home. Thanks for diving in with us on System Design from the Manual J. Remember, we're here for you at cleanheatconnect.ny.gov with more videos, resources, guides, and best practices. Hope to see you in our other sessions as we complete better installations together, one project at a time.